Good morning.
How are you doing today?
Okay.
Where are you located, Ed?
I'm in Cleveland.
Oh, okay. Do we have any hints of spring yet?
Not really.
It's a rough one, isn't it?
It was 70 yesterday. Today's in the 40s. I just
Oh, do you see my video right now, Ed?
yes, I do.
Okay, cool. Have you been using Zoom quite a bit with school lately?
I've been using it a little bit. We've been using Meet for the
Oh,
most part, and then when I do face to face, I tend to use Zoom. Like if I'm doing a whole class where I want the whole class.
and have you succeeded in getting the students on board? No problem there, right?
So far, no problem. Tomorrow will be the interesting class. Well, actually, no. Friday, the kid never showed up.
Oh.
Said okay on Thursday, but then didn't show up on Friday.
It's like, I got better stuff to do.
So
Wow. That's a new way for sure.
yes, but the class the day before on Thursday, everybody showed up. So
Yeah, good. I mean, they're automatically competent with the technology too, aren't they?
for the most part,
For the most part. Yeah. Hi, Cheryl. Your audio doesn't work yet. You're just muted.
Good morning, Ken.
Hey, good morning. How are you today?
I'm good. So I disassembled my robot so that I could put it together right.
Well, actually, it's okay if you did build it like I said, but it's a lot easier the way I'm going to show you.
I'm all in for easy, so I undid it.
Yeah, good, good. It has to do with, and I'll repeat this several times, but there are two ways that you could put these motors in. One has the spline closer towards the middle, which is a tighter turning radius. And the other way, if you flip the motor, if you turn it 180 degrees, the spline, like the shaft, is further forward. And it turns
Okay.
better when the wheels are closer to the center, much like a Roomba. And the challenge with that setup is the potentiometer you can only get to with this setup before you build it. So it's back here. So
Uh,
now it's kind of, hidden by the battery pack. But if you built it per our instructions, the potentiometer is right here. It's easy to get to, but it does not turn as well. This is one of those things that, people familiar with our stuff know intimately. And they are very aware of all the servo, centering, calibration type issues. And now you'll get familiar with it too.
yes.
Part of it is the long-standing desire to keep the chassis the same so we do not obsolete our hardware that's out there,
Okay.
as you can imagine.
I think Jen just needs to get laid. Someone needs that. You know, it's crazy, man, because most of the whole trailer, I barely heard a peep out of your mouth. It is a tough balance. So
Cheryl, where are you located?
I live in Victoria, Texas, but I
Oh,
work at the University of Texas in Austin and Region 3 Education Service Center in Victoria and do a lot of teacher professional development.
oh, great.
I do some work with NYSERC. So
Uh-huh.
you know my buddy Tommy
Yep.
Gober? Yeah,
Yep. Known them for 10 years.
yeah. He and
And
Chuck. Um, but Tommy the most, he's done a lot of training for us. And I first saw the Cyberbot. Tommy had it at a session he was doing just to kind of, tease us a bit. And I was like, oh my gosh, I want it.
I'll take one of those.
Yeah. I've done a fair amount of training with the microbit with teachers and some with kids.
Focused on the make code or done some Python as well?
No, we've just done the make code, the block programming right now. So I'm real anxious to transition to the Python.
Yeah. Well, that block code is really nice, I have to
Oh,
say.
yes.
The fact it has a simulator and you don't actually have to have hardware makes it a winner right now with distance learning, doesn't it?
Yes, for sure. And where are you located, Ken?
We're in Rockland, California.
Ah,
Yeah, Sacramento, 2 hours from San Francisco.
yeah. I've been to Sacramento.
Okay, Rockland, if you kept going past Sacramento towards Reno, then you'd encounter Rockland.
Mm. So it's early for you in the morning.
Yeah, it is a little bit. But, you know, lately, with this quarantine, it's just been work, 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 and schedules are just kind of blending, days are blending together. And
Yeah,
so I don't really mind getting up early. I think everything is getting redesigned the way people function right now, isn't it?
for sure.
Some things aren't going to go back.
I'd imagine, right?
Morning, Ken.
Good morning.
This is Ed Stenny here.
Ed, good to hear you.
Yep. It's later in the day for us, obviously, on the East Coast.
Eating the turkey sandwich already.
Yeah. Getting ready. It takes longer to get stuff done. But I just received a document cam this weekend. So I think things are going to work a lot better.
Oh, nice. Yeah, I could really use one of those today.
It's almost impossible to teach math without it. I've been cutting stuff off the screen using this one tool that Windows has. Was it Snap Edit or whatever?
Mm-hmm.
And then they have to put up with my unsteady hand trying to teach algebra. So should go better this evening.
Yeah, you know, it's a work in progress, and just figuring out the tools is an impediment to communicating, isn't it?
It is. I really do. Well, once you
takes
pick them
time.
up, I mean, I've been meaning to get a document cam for a while. Because working with the homeschoolers, you know, you can't go to the libraries now, can't meet anywhere. So this will help with the robotics as well, because you know I can show a picture now, show it moving around. So this makes good sense.
Yeah, I think we've had several teachers drop ship robots to students, and I'm kind of wishing we had like a $29 robot that would be really cheap to deploy to everybody. But you know, when you have a $29 robot, it's impossible to support the rest of the ecosystem around it. But
Yeah.
we're finding that this would be really useful right now. And then people have asked for simulators as well.
Yeah, I can see that happening.
Hey, Ken, can you hear me? This is Stephanie.
Hi, Stephanie. Yep.
Hello.
Good morning.
Good morning. I do not see that I am a co-host.
Let's see here. How do I change that? I definitely set you up as well.
What happens if I pop out of this? I'm gonna try.
Okay, I got you, Stephanie. Here we go.
Okay.
Yep. It's just a setting for me to change with you.
Okay.
So your name is a moving target. Every time someone jumps in, you go down a notch. So I clicked on, making Ed Stenny a co-host.
Oh.
Might be a better idea.
Okay, check now to see if you have some control.
I do.
All right. And your headset, are you using a headset or speakers on microphone on the computer?
I'm using a headset.
Okay.
Am I audible?
Yeah, you are audible. Uh-huh. Yeah.
Oh, look at that gripper.
You like that?
Nice.
Of course, spent my weekend messing around with this. fact, while people roll in here, Stephanie, you can admit them, I think, as they show up.
Unmute them.
Admit them, admit them. Just going to do a little bit of testing here. The difference between pin and spotlight. So I've spotlighted a video. I don't know what that does for all the viewers, but it makes it large. And now I'm going to pin it. I don't know if that changes your view or not. In this mode right now, which is pin video, does it occupy a full screen for anybody?
I'm in speaker view. If I click out of speaker view, then I can see it.
I'm seeing a
I am full
screen, but it's doesn't look like it's full screen. I mean, there's black margin top and bottom.
Oh, interesting. You don't see the, let's make sure I got my sharing right.
I'm seeing like the presentation distance learning with Cyberbot and Python.
Oh, okay.
Yeah, that's what I'm seeing as well.
All right. Do you also see a video with a gripper and a microbit?
Yes, off to the
Yes.
right.
Okay. And just for kicks, when I'm curious what this does when I unpin the video. Do you still see it?
I'm seeing it to the right.
Okay.
I'm seeing the same as before. Yeah.
All right. I'll have to research that feature in Zoom. They have some features in Meeting which are not present in Webinar and vice versa. Well, we're still spooling up a bunch of people, so we'll wait a bit. How is everybody today? This is kind of cool with the video, isn't it?
Yeah, this is neat. We're getting really good at it with this distance learning as teachers.
I'm glad you guys had practice for 2 weeks before this. Well, we're going to try to set a new bar because I'm going to be asking you to split screen Zoom with a Python editor.
Okay.
So it's a challenge.
So how do you get the little video to run in addition to your desktop with the like the PowerPoint?
I think you need to go find the gallery view.
No, I'm seeing it. I'm asking, how do you manage to project two different things at the same time?
Oh, okay. I think just as host, that's automatic. I believe that's how it works.
Well, that's where you have the cam is focused on this, right? You're switching between the two, right?
Mm-hmm.
That's how that's happening. Okay.
Got it.
So you're,
Yeah, I think as
you're
host,
presenting the
you see me and all of you, and I'm just switching around video sources. Because you do all see one another, right?
Yes.
Yes.
Okay.
Yes.
Yep.
Hey Ken, how are you switching between your cam and your document cam?
Okay, so there's a control bar for presenter, and stop video has to the right of it a down arrow.
Oh, okay.
And when you choose it, when I choose it, then I can choose all video sources that I have.
Okay, so you choose your video feed. Okay.
Yeah, so I could just kind of alternate between
And maybe
that.
we need to add another section called Zoom meetings for educators.
Well, let me tell y'all, I mean, if you find Zoom challenging, Stephanie and I have been using it for webinars for years, and it is difficult to be able to communicate and manage the tool. No, we try hard, yeah.
Yeah, Ken, you said you were going to have us split our screen. Right now, I have my Zoom on my iPad, and I have my laptop adjacent. So
Great approach.
Okay.
Yeah, if you could do that. In fact, I meant to point that out as a possibility. If people want to have a tablet, that's the best way. You know, I mean, you take our whole office and we probably have 2 or 3 people that can really effectively manage multiple displays well. I'm not one of them. Well, we're loading in. We have 47 people in this meeting. Can you believe that?
Wow.
You're all enthusiastic about the subject material. It's great.
Well, thank you for setting this up.
You're
Yes.
absolutely welcome.
Yeah, I'm watching the governor of Maryland is just going into stay at home. And so I'm expecting my state, Virginia, is doing that today. So,
Yeah.
We've been doing it
So
for like
I was
3
in a
weeks.
Zoom last week with 380 people.
Wow.
Was that a webinar?
It was a Zoom meeting.
Oh, a meeting. I didn't know meetings could get that large.
I didn't either, but there were that many of us.
you have to pay extra for that kind of accommodation.
Sure,
That's not free Zoom.
Yeah,
No,
yeah, I was
renting a big
one
hall.
with 700 people.
Well, while we kind of load things up here, I'll give you the look around my shop. These are some various robots set up for different things. Some cyber bots, some activity bots. And this is actually remote from our main office where I am today. These are just kind of robots, electronic components I got ready. And then here's the main office area. And my workshop just consists of basically some drawers and big workbench.
I'm not going to show you my home office because it's a mess.
We might have an award for you.
It's a good thing I can't participate as an employee or I'd win that one.
That's why I have a fake background behind me.
That's great.
Ken, are we going to use the microbit editor for Python?
Yeah, we will.
Python.microbit. Okay, I was just getting it all set up here.
Yeah, that's good. If you guys want to, you can get a browser window with that open. And no worries, I'll take you there.
Ken, is it if we use the Mu editor?
You can, yeah.
Okay.
So we have about 60 people in here now. Just added Kevin Knowlton from NYSERC. Well, how about if we get underway here and we'll let the stragglers jump in when they show up. They're definitely probably setting up Zoom and that could take a while. Okay, so before we begin, even before introductions, once you're here, so it looks like you're already familiar with Zoom because you all have control over your own microphone. You can leave your video on, especially if you want to show something. And your microphone, just try to mute it unless you got something to say. But we have about probably 70 or 80 people rolling into this meeting. And so I'm just going to allow you all to unmute your microphone and chat whenever you want. Okay, so yeah, that actually helps. That way if your dog's barking or whatever, or your coworkers are noisy, they don't affect us. But yeah, from time to time, though, I want to hear your auditory feedback, actually, as often as you want to give it and as often as you want to make a chat. You just jump in. Well, good morning, everybody. Everyone's good? Okay, excellent. This is going to be fun. We're breaking new ground today. Usually we do webinars, but we're kind of running a mini class with you all. And this is something we've not done because we're going to be having you hook up hardware and we won't be able to see everything you're doing. So there will be some new frustrations, but also new achievements made here this morning. My name is Ken Gracie and I'll switch over my video. Yeah, good morning. My name is Ken Gracie and I'm CEO of Parallax. I've been working in educational robots for 25 years now. And yeah, today we're talking about the CyberBot. As I mentioned before, this is a new kind of way to run a distance learning course. Usually we're in front of teachers for a full day. Okay, so we had to really pick and choose what we're going to achieve with you today. Distance learning is interactive, so I want to hear your shout outs and your comments, your questions. Just bring them forward. Nobody be shy. It doesn't matter if you're in your pajamas. You can type them, unmute yourself, ask them, whatever. It's very important for that two-way communication, so I'm not just wandering off into the bushes here while you don't know what to do. So things can happen, things will happen. This is kind of like building an airplane while we're flying it, and that's what makes it so much fun. We have an award ceremony on Thursday. Actually, it says 4 categories, so there are really 3. The first is funniest animal or coworker. So we all know the deal now. Our colleagues at home that are stuck at home with us are now called coworkers. And so if you get a cat, dog, funny animal or something like that you want to show off, just do it, okay? So we'll pick by probably Wednesday evening something we've seen from all of you that we thought was sort of funny. You have to draw our attention to it, and then we'll hand out awards. Category 2, the biggest fail. We invite and welcome failure. Sometimes robots can be a little bit frustrating to work with, but that's all part of the learning process. You have power supplies, electronics, coding, circuit building, pretty much everything, unplugged, plugged in. So there's a lot to work with, but it really teaches students to be methodical, and it's very rewarding. And category 3, the biggest winner. So this will be on Thursday. If you've done something you want to show off with your Cyberbot that is unique, bring it forward, and you may become the biggest winner. Where are you guys from? So this is interesting. Pretty much spread around the country on the seaboards, as you'd expect. And then Texas is always a popular place, and North Dakota, Chicago, Wisconsin area. We also polled you for your experience level when you signed up. This is what you told us. Yeah, so some of you are already using robots. Some of you Lego, Vexvero, some Parallax stuff, some electronic experience. This is really neat because in years past, we would have had a very small percentage of people that had done any kind of breadboarding or circuit building, but now it's becoming pretty standard. So this whole STEM effort, we've seen it work very effectively in slow motion. Tech tools. Many of you have some kinds of tools in your class. Most of you are operating on Windows. So that's good because I'm using a Windows machine, but everything we're doing here works with Chromebooks just as easily and just as easily with Macs. And your students are mostly high school, some middle school, and then we have a few elementary as well. And we just asked you some other open-ended questions, and looks like you're all excited. You're thankful, and that's so nice to hear. And we got a lot of interesting emails back from you the last week while I was flooding you with messages. So here's our agenda, and would welcome your feedback on this. I didn't get too detailed because it will definitely adjust as we go, but today we will pretty much have an introduction to Cyberbot. We will get connected. So we'll connect the microbit to the Python editor, and we'll write a few simple Python scripts. That'll take us probably about 10 minutes. The connection setup with this particular product is nice and easy. And then we'll add a code module to the microbit. It's a Cyberbot module, and it's a series of steps. And that next we will hook up, as I mentioned in the last email I sent you, we will hook up the Cyberbot board to the microbit, plug in a power supply, and then calibrate our servos. Take off today. You'll get to build the robot between today and Wednesday. Some of you already built it and already took it apart. You had so much fun. Wednesday, we will focus on driving the robot around, and then we'll get a little more into the Python side of things. So to get to that Python goal, we've got to get a robot together, get connected, so on and so on. But once we have that achieved, then we can really start writing some code using loops, functions, parameters, and our libraries. So at that point, we will have really broken some big barriers, I would say, and we'll be on our way to circuit building. So we'll probably build that first circuit right here. And this gives us a wonderful chance, Stephanie and I, to give you some tips on circuit building that apply to everything. So we're trying to hit all of the big barriers that may lie in the way kind of topically. Then Thursday, we'll show off some advanced projects in the tutorial, and then we'll get into cybersecurity tutorials. This particular device we're using, the microbit, is really nice for cybersecurity because it has a built-in radio. So it lends itself to encryption, decryption, and wireless communication with channels right in your classroom without any kind of servers or IT staff or anything else to wrestle with. And that's something I like about it a lot. Have our award ceremony, we'll talk about using in class. For all of you teachers, have fun, participate, learn what we've got, understand how the pieces work, and then get confidence. And we know this is a biggie. I'm also a preliminarily certified CTE teacher in California, and I've done on and off 7 years in classrooms. And I know what it's like to stand in front of a class when all the kids are kind of deflating and you're losing their attention. And we're going to prevent that from happening with you. So there's our CyberBot. CyberBot is actually a joint project of Parallax and the Cyber Innovation Center. They're here online. I don't know if any of them want to just pop in and say hi. I think I saw Kevin.
Hey.
Oh, good morning.
Yeah. How are you, Ken?
Great. How about you?
Oh, we are doing just fine. It's another day in the home office.
Tell these teachers about NYSERC briefly. Some of them know and some of them do not know of NYSERC.
Yeah, so we're really proud of the partnership that we have with Parallax and the development of the CyberBot. And NYSERC, for those of you who are not familiar, is an organization that's grant funded by the U.S. Department of Homeland Security, and specifically their Cybersecurity Infrastructure Security Agency. And we have grant dollars that allows us to develop K-12 STEM, cyber, and computer science curriculum and give it away for free. And so all of our cyber curriculum at the high school level uses Parallax's products, whether that's the BoBot, the Arduino Shield Bot, and then the recent addition to the fleet being the CyberBot, which we're going to learn about today.
Awesome. Thank you, Kevin.
Yeah.
And those of you who don't know Parallax, we're located in Rockland, California. Everything you're using today, we manufacture in this office. So we'll come back to this. It's going to become very apparent. CyberBots, by the way, have been out for just over a year, I think. So we're finally getting a lot more feedback from students and teachers. And speaking of them, this is really all about them. And this kid right here, Zach, would not leave my USA Science Engineering Festival booth. For 2 days, he came and built everything I had. And I just want to use him to point out that exposure to this kind of thing creates careers and interests, which really drive the economy. So this is one of the few chances students get to really do things under their own control, which is what they all want so badly. Well, how do y'all feel about just jumping into some programming with the microbit? All right, okay. All right, so I'm going to fast forward. These are some webinar slides and just get you all connected. Okay, so all you really need right now is your microbit and your USB cable. So go ahead and grab those things and plug them into your USB port. And then I'm going to take you to the Python editor and show you how to use that tool. Looks like you're all getting connected. There's a silly little cool little thumbs up tool you could use in Zoom somewhere. Of course, once I found it, it disappeared on the screen, but I guess you could use the chat too. All right, so good. Looks like you're all connected. All right, so we want to go into the Python editor, and it's python.microbit.org v2.0. And by the way, I did not properly introduce my co-host. Stephanie Lindsay is here, and she's going to make sure that I keep things in order the right way and help answer technical questions. She's monitoring the chat and can deal with any disasters before they happen. So just to make sure you've all got my screen, my Python editor. All right, good. Okay, so once you open this up, it always opens up with this one program in it. And there are basically 3 ways that you can get your code downloaded to the microbit. I'm going to show you those 3 ways right now. So the first way is really the preferred way. And based on our success with this, we'll look at the other 2 ways. When you plug in your microbit, and this is one of the joys about using this particular product, is that it shows up as a USB hard drive. Okay, so it has its own operating system in it. And this means that there are no microcontroller drivers to install, really nothing to install. Provided you can plug in a USB thumb drive, you can plug this in, it will simply show up. And if you've updated your firmware, you should be able to do what I'm going to do right now. So in my Python editor, I have this connect button available. And once I click on that, and you guys can do this too, and you might need to arrange your windows here so you got some things side by side. When you click on it, which says paired, and then click connect, you will notice that the top left button changes to flash. All right? I'm curious if you all are seeing that. So maybe a message here or there. Okay, I see a couple thumbs up. All right, it's not the end of the world if you don't see that.
Yeah, I'm seeing that.
Okay, cool. Anyone just not seeing it? I'm looking to peg the meter here, like 80% see it. 20.
Yeah, Ken, Gene Clifford, I'm not with you.
Okay.
There's a request to do it again.
Okay, good. All right, so.
Yeah, I'm kind of stuck too.
Problem?
I was using Firefox and it told me I had to change to Chrome, so I did.
Yes, thank you.
I was
Overlooked
using
that
Safari.
detail.
It did the same thing too.
Oh, great, great. Yeah, so be in Chrome. Okay, that's the requirement did not mention. So be in the Chrome editor if you have it. If you don't have it, you can go ahead and install it right now and then come back into the webinar. All right, so when you open up the Python editor, you'll see this screen. And your microbit, if connected to your computer with the USB cable and its firmware are updated, you will see this button that says connect, second one over from the left. Click on it, and then up comes a window like this. It says Python editor wants to connect to the microbit. Click connect. All right, and once you do that, I want you to notice the button on the far left goes from download to flash. Okay, now if that wasn't possible for you, then I'll show you the second and third ways to get code into the microbit. So provided that did work, all you have to do now is hit flash, and then the microbit will be loaded.
Ken, if we have someone who's stuck in a loop that just says connecting, but it's not actually connecting, do you have any hints for that?
No, that could be, possibly a computer type issue, maybe reaching the this Python web page. So I haven't seen that before though. No. Okay.
They might need to, you could check with whoever's encountering that and see if they updated the microbit firmware.
Yep. Thanks, Sandy.
Mm-hmm.
Okay, so the second way would be this. So just click on download. And then this is if you're unable to connect. If you just click on download, then it will generate a hex file. And then it should.
Ken, where am I downloading from?
Okay.
I switched back to Firefox.
Okay, be in Chrome. Do you have Chrome on your computer?
No.
Okay. So you could do this in Firefox and you'll use the method I'm going to show you right now. All right, so do you see the download button on the upper left of the Python editor?
I don't have Python editor open.
Oh, okay, go to python.microbit.org And then you'll wind up, I'm sharing the screen that has also the URL on it.
Ken, while we're waiting,
yeah,
this is Jim Eggenrider.
Morning,
I
Jim.
did not see paired show up the way yours did, but it worked anyway.
Okay.
And I'm using 0253. I think that's probably what you intended.
All right. Yeah, and I expect some nuances here. So we're using hardware and software from 3 different places. And then you guys are all on these different browsers. So the ideal situation is always Chrome and then microbit firmware that's fully updated.
Okay, so this is Gene Clifford again, Ken. I typed in my microbit, my Chrome, and I've got, I want Python editor for microbit, is that correct?
Yeah, so just go to the following URL, python.microbit.org.
Okay, and now I've got the screen that you had before.
Oh, perfect, okay.
It says file true.
All right, so
Ken, I have a question. This is Erica.
Hi, Erica.
This is what we were assigned for homework last night, right?
Yeah, light duty homework.
Okay. I just wanted to make sure because I switched off. I've got the Zoom running on my phone and I've got my actual microbit connected to my laptop because I need 2 screens.
Yeah, that's a good approach. Yeah, and we have time to get this right. This is the biggest, the biggest hurdle is just getting connected to hardware. So these are all good points. So let me take you back to the first way, since a few more of you have just jumped in here. When you plug the microbit in, if you see the connect button, this is your preferred way to get code into the microbit. If you click on connect, then the flash button becomes enabled. Okay, you might have to click on connect and then choose the microbit and then pair it, all right? But if that works, and most likely works because you're using Chrome and because your microbit is firmware is updated, the flash button becomes available. Now this directly puts the code into the microbit from the Python script on your screen to the microbit. So you click on flash, you'll see this. So the second method, okay, if that was not possible, is this. You might see buttons that say download and connect. Okay, so when you download, you're generating what's called a hex file, and it's going to package this up and save it in your browser's default download directory, okay? So in mine, you'll see something a little different may happen than yours. When I click on download, I get a, hey, where do you want to save it? All right. And so I get to choose. And so I'm going to save that program in a folder where I know where it is. Okay, so the program is not on the microbit yet. I've just saved it. But I need to open up a Explorer window. Try to do this in a way that looks visible for all of you too. Okay, my windows are also kind of moving around right now, so give me just a second. Okay, we'll do that again. Okay, so I click on download, and I'm going to save it just on my desktop. Keep this really simple. And you notice it's saving as something called microbit program, parens 1 hex. That name is what the next version number of what I have in the script name of on the right side of the Python editor. Don't worry about that yet, just save it. So now I've saved it on my desktop. So at this point, I need to drag that file from my desktop onto the microbit. And just want to make sure you can see my Windows Explorer right now. Thumbs up on that. Okay, you guys see the Windows Explorer that I'm looking at?
Yeah, see
Okay,
it.
cool. All right. So I found the hex file, and then here's the microbit. Just going to drag it onto it. Okay, now it's on there and it's running. And so what do I see is this. Okay, so there are two ways of getting it onto the microbit. There's actually a third way. All right, I'm not going to go over that right now because it takes a lot of time, but it works like this. Click on Load Save, and you can actually drag the hex into this window. So it could be beneficial. You might even set up like an Explorer window on the left side, and then this window on the right, and then you can just drag from the left to the right. Now,
is it possible to name the file under download so you don't wind up with a directory that says microbit program 1, 2, 3, 4, etc.?
okay, so you'll need to rename it each time you download it. It's going to save it in the directory that your Chrome browser is pointing to. So, for example, if you normally just generate a hex file, it's going to go into the default downloads folder. But in Chrome, you can go into settings, and then you can pick, just like I'm doing right now, if you go to Save As, I think this is the right place. Or Andy might tell me if I'm wrong here. What's the location of that, Andy?
Sorry, Ken, I don't remember off the top of my head
Okay.
either. I'll look it up and chat everybody.
All right, cool. So yeah, Andy will show us how to configure Chrome so that you can save, choose the destination directory. So the program name is up here, script name. So I'm just going to call this Heart. I'm going to rename it. And then when I go to download, it's going to put it wherever the direct last place I had open was, and here it's called heart.hex. So I'm going to save it. But I would prefer just to flash it directly to the microbit. So I'm going to go to that connect button, connect back to the microbit, and then flash. Okay, so you choose the name here, and you have two ways of downloading code to the microbit. Kind of give me a success level indicator from everybody, maybe through the comments or voice or something.
I'm going to speak up from a few comments. You go to Settings, Advanced Downloads. Thank you, Neil, for controlling where your Chrome is going to download to. There is at least one person who still cannot get the microbit to be recognized as a device in Windows. That happened to me too when we were initially setting up the tutorials. I'm going to put some links down here in the chat. One is a page out of the software setup for microbit tutorial, and this is the specific page. And down in this page, there's a little iBox that has a link to a support page on microbit. I had to go through these additional steps and get rid of one kind of device and let it be recognized as a different kind of device. There was some override that was happening that was not allowing it to be recognized properly. Only one in the office that happened to, but we added that link just in case. So if anyone else is having that difficulty, that's another direction to try. And
Okay, thank you.
And Sheila is saying that they had to reset the microbit for it to show up.
Right, you have to press the button and then connect it. Yep. Okay, good. So most of us are here. Those of you who are not, don't worry, we could hang out on the webinar afterwards and start and just sort through those issues a little more. Okay, so let's modify this code a little bit, and then we'll write one more program, and then we're gonna go straight into adding the library. And I know this is a lot, pretty fast, but it's okay. These are the big hurdles. So on my code, I'm just gonna change the sleep 2000 to sleep 1000. And then I'm going to do a carriage return, and I'm going to type in another display.show. And I'm going to say this time image.heart_small. And then put another sleep after that. And I think I'm going to comment out the hello world, okay? And you can do that just with a hashtag, or what we used to call a £. And when you download this, it might be fun to make the heart beat more realistically. Okay, there's 60 beats per minute. You will see the following. All right, anyone got a beating heart? Okay, here y'all typing, that's good. Let you work for a minute. All right, so if you're getting here, it's a good thing. You're on your way.
This is Erica again. Can you explain what the 500, what unit of measure that is?
Yeah, those are in milliseconds. Yep.
Thank you.
You bet. Which brings me to the first share, which would be the microbit MicroPython reference guide. Okay, so we're just using right now predetermined images, which I'm showing you. There's a whole bunch of them. And we'll distribute these links, but there are many built in. Silly, fabulous, yes, no. You can try them if you want. But this is the complete reference guide for MicroPython for the microbit, okay, that I'm showing right now. And I'd like to reinforce, definitely the way to learn to code anything is by having examples, and that is a great place to get your examples. Okay, so we've got a beating heart. Let's then, just for fun, take a look at, there's a number of things we can do here. And probably because of time, I'm just going to show you a great place to get a lot of code that you can also use after this, because you know how to download now and connect your microbit. So the site I'll take you to, and I will be distributing this video on YouTube, so you don't have to take notes. But it's the BBC Microbit Make It Code It site. And let me show you how to use it. There's a ton of different projects on here, many which require no external connections to the microbit. So it's on microbit.org/projects. And then once you go there, you can navigate to Make It Code It. I'll zoom in a little bit so you can all see this. Here's how I've been using this site. You can check on make code, which is the block code, or on Python, okay? So let's say we're interested in Python, just choose that, and then go down, and this is what's really cool right here. So device feature, what is it you want to see coded in Python? You want to see the accelerometer? Compass, oh, I didn't know there's a compass on there. The radio, oh my gosh, the world just keeps getting bigger and bigger. So yeah, click on accelerometer for fun, and then it gives you a bunch of projects. So let's see if I can find one that I really like. Okay, well, we'll just get one for kicks. Dice. I'll click on that. And there's an explanation of how it works, what you need. As you scroll down, you see the make code, and then there's also Python. So if you click on Python, you can actually open that code right in a browser. Or you can download the hex. So this is pretty darn powerful to have this kind of access. So nothing was downloaded, then opened in the editor. So if I open that up in Python, their code comes in like this. I am going to connect to my microbit and download it, and then I'll show it to you. It's the first time I've seen this code, so I don't really know what it does. So there's an ability, a function that determines must be true when shaken. Okay, and so when I shake this, it increments it displays a random integer between 1 and 6, according to the Python code.
Oh, it's like dice.
Yeah, I guess it's the dice. Thank you. And there's also a pedometer and some other cool stuff in here. All right, so that's the Make It Code It site. You all find that useful? I think it's pretty good. Okay, so let me open up another program, and you can type this one if you want, but this is a show and tell, just to show you that there's a terminal here. This is a code that I wrote last night, and I call it display scroll. Okay, so it's really a for next loop or a repeat loop, and it will count from 0 to 49 because in Python we exclude the last number, and then it will write to the display the value with the delay of 50 milliseconds. And then I add this line of code, print. Okay, so this will open up, allow us to see it coming back to the computer. This is a way that you can tell what's going on inside of your microbit. Just simply insert this print command. So I'll download this, flash it to the microbit, and this may not lend itself well, but those numbers are incrementing 4, 5, 6, 7, 8, 9, 10. And if I open up serial and I reset it, then I should also, here it is, see the numbers scrolling into the display.
Sorry, I blinked. Where was cereal? Oh,
Yep.
yeah, right there.
Yep. And so one thing that's funny about these menus is the button names are always changing, okay? So you click on open serial and then it becomes closed serial. So that's kind of nice. All right. All right, how's everyone doing? So far, so well, okay. All right, no one's, well, okay, good. All right, so then we can move on to something kind of big. It's the next big step here, and it's downloading the Cyberbot code module and putting it on the microbit. Okay, so there's so much I didn't explain about the microbit, but that's okay for now. What I'd like to tell you is that all of the robot functions are possible because we have a code module that talks to the microbit and makes things possible. And that module is called the Cyberbot module. And I'm going to show you how you would go get it in our tutorials like a student would. So the tutorials for this are on learn.parallax.com. And in fact, you can all just go there right now. I am going to do this on my own and then come back and walk you through it, okay? Because it's tricky. So we'll be getting a library, a module, downloading it, unzipping it, and then adding it to the microbit. So for the first time through, I would just say, watch me, and then I will walk you through it as well. So I went to learn.parallax.com. Again, just watch for now. And I scroll down to the Cyberbot and I click on it. All right, this is the whole tutorial series. You'll see the prerequisites, and then there are the main lessons, and then projects. I happen to know these quite well, so I am just going to go to where I need to go. I'm going to go to add modules to your microbit. And in here, there is a link on the top. This describes pretty much what we're doing. Download the Cyberbot library archive file. So when I click on that, it takes me over to the Parallax site, and then I see that there is the highest version, which is the newest, and then some older ones. We keep these older ones here in case they're needed, but I think everyone knows you grab the latest one. So when I download that, ask me where to save it. I'm just going to put it on my desktop. Okay, now it's there. And then I'm going to go to the desktop and I'm going to unzip it. Now, zipping has become a funny thing in Windows. If you double click, it shows you the contents, but it does not unzip it, okay? That's a new feature that causes confusion for people. Just right click on it and then extract all, and then tell it where you want it. And I'm going to put it right on the desktop. Okay, so then it made an unzip on my desktop. Well, oh, I'm organized alphabetically, so yeah, it's over here. That's a little bit confusing. Okay, so now I have the library unzipped, and if I look inside of there, you'll see there's a folder, and then there's a whole bunch of libraries, and then all the code examples that go with the Cyberbot. Okay, so that's nice to have. Now, I want to add this Cyberbot module to the microbit. I'm going to show you how to do it. We have a video on YouTube for this as well. So I come back into the Python editor. Okay, And I'm going to use the load save button. So I click on load save and I see this window. Control plus and minus, by the way, is really handy with this editor. It says drag and drop a hex or PI file here to open it, or browse for a file. And I want you to notice down below it says show files 1. There's just my program on it right now. That's all that's there. So show file says 1 at the moment. Browse for a file, and I'm going to go to that cyberbot.py that I unzipped. It's right here. Open it up. And it says the cyberbot module's been added to the file system. Okay, cool. But I want to verify that. So go back into load save, and now you'll see it says project files 2. Hey, it said 1 before. So one of them is my program. The other one is the cyberbot.py file. So now I have the cyberbot code module on my microbit. And the benefit of that is we can run the robot, but we can also say, change the code to say from cyberbot import star. And this cyberbot library includes all the commands for talking to the robot. So I want to walk y'all through this and see if we can get this done online. Everyone game? Okay, cool. All right, so the process works like this, and I will do it slowly. I will start out on learn.parallax.com, and I'm going to scroll down till I see Cyberbot, and you'll see it under grades 9+. Click on Cyberbot, and then you will see this page, the tutorials. Scroll down to the prerequisite that says add modules to your microbit. I'm going to pause there for a minute. Any thumbs up yet? You guys, give me a few head nods. Okay, I see a few are getting there. Okay,
Yeah,
don't worry. Yep.
Getting there.
Okay, cool. Yeah, it takes time. Maybe this is so much faster than our live classes too. This could take an hour in a live class. So once you find that add modules to your microbit, just click on it. And these are the instructions for adding the module. But we can forego the reading at the moment and just click on that first link that says download the Cyberbot library archive file. Give me a few thumbs up out there. Keith, Matt, Cheryl. Okay, good. All right, Erica. Okay, all right, so I click on that, and then you go to the main Parallax site. That's because we host all of our files here. And you're after the first link. Cyberbot MicroPython v080. So you want to click on that and then download it. Put it somewhere where you'll find it. Default might be in your downloads directory, but it might be best to put it on your desktop. And then save it. Okay, y'all with me? Thumbs up. Okay, pretty crazy what we're doing, huh? I think it's crazy. Pushing the limits around here for sure. Okay, and then go to your desktop, right click, and then extract it. And I've only got 20 extractions of this on my desktop by now. And you'll see a folder. Make note of where it is. Okay, thumbs up so far. All right, process is a little bit different for Chromebooks, but pretty obvious from when I've done it.
Ken, I got the Cyberbot MicroPython file folder, but I don't see, I need to save this to, no, actually, still thinking. Oh, actually,
Okay.
I'm not responding, never mind.
Okay, computer froze a little bit.
Okay, so I'm gonna, yeah, what do I do with this guy now that I have him?
Okay, did you extract the Cyberbot MicroPython folder?
No, it just says Cyberbot MicroPython. I'm just looking
Okay,
at the folder.
that's good. So now right click on it and then choose extract all.
Extract is not one of my choices.
Okay, then try double clicking on it.
Okay, now I've got, it's opened up and it's given me Cyberbot PY file. Is that what I
Okay,
want?
yeah, so hopefully what you're looking at is actually an unzip. So if you could just grab that Cyberbot PY, maybe put that on your desktop.
Okay.
So you can have that available for a next step. Yep, it's good. Okay, I think we're all pretty much there. So I'm going to go back into now the Python editor. Okay, and I'm going to add the Cyberbot library to the microbit. So once in here, it doesn't matter what kind of script I have. I could just delete it all for fun. Click on load and save. And you will see this window. And I'm going to browse. And of course, one alternative is you could drag and drop it on here. So I click on browse for a file. And then I go to where that cyberbot.py was. Select it, click open. And in my case, since I already had it, it says, do you want to replace it? I'll just click OK. Yeah. All right, so some level of success out there.
There's questions are coming in that I think are relevant right now.
Okay.
One is, do we need to do that every time we flash the microbit?
No, once is all you need. Just
long-
once you put it on there, it should stay. However, occasionally it does kind of disappear. Okay, it used to be a problem, but I think this is improving. So if you get a syntax error when you're writing code for the Cyberbot, it may be because your module's disappeared, but generally just once.
So the two pieces for it are making sure you've put that file onto your microbit, and then the second part is making sure you reference that file in your program. And that's what we're about to do here. And that way you have access to all those new commands that Andy created for the Cyberbot.
That's right. Okay. So what Stephanie said was once you've added it, and give me a gauge here, who's got it? Thumbs up. Okay, all right. Some are like, not sure yet. Okay, but that's okay. Okay, good. I see a lot of thumbs up.
There's one more relevant question here. When students log in and out of computers and in and out of their browsers, will the modules stay? I would say the modules are actually on the microbit itself.
Can I jump in here?
Please do, Andy.
Okay, so we looked at a couple of different ways to save your work. And when you click the load save button, Ken, could you click the load save button for just a sec? See the download project hex? When you download that, the file that Ken dragged in is going to be saved. So Ken, if you save that, then what you can do is and we wouldn't want other people to do this, but Ken, if you were to refresh your browser, it would basically make all this go away. And then heart on hex in the lower left, you can drag that back into the Python editor, and everything that you saved, including the Cyberbot module that you added to the project, will be there. It does not live in your microbit. It lives inside the project.
A little bit. Hey, turn the air conditioner on.
All right, so next up here. So
Okay,
we've
so
got the
the
module on the,
final
okay, I'm just
version.
gonna read comments really quick. Jim says, my Python screen did not change. I still have the heart. Okay, yep, your screen won't change on the microbit, the display, because we haven't put any more code in it, so that's right. I think we're good to go. All right.
There was one question. I have it saved on Python now. How do I get it to the microbit?
Oh, so then you go again back to press the flash button, and that will download it to the microbit if you've changed your code.
I also have a question. On yours, it says Cyberbot import. On mine, it says microbit import. Does that make a difference?
It will in a moment, yeah. So that's where we're going now. So we were using the microbot module, and now we're going to use the Cyberbot module. This module has in it all of the commands for the robot, plus the microbit module we were just using. Okay, so you could go ahead and change now from microbit import star to from Cyberbot import star. Go ahead and just type that over. And where we're headed at this point is we are going to use this module to do what's called center our servos, okay? So I'm gonna switch my camera display over to servo connection. And I'm gonna do this first, and then I'm gonna have you guys actually assemble your microbit onto your board. Okay, so what we want to do is we want to center these servos before we build the robot. And the reason we would like to do this is because we can install them two ways on the robot. Let me give you an example here. All right, these servos have a spline on them where the wheel attaches. And in this case, the spline is closer to the battery pack, which gives us an overall tighter turning radius. If I flip those motors over, the wheels go forward about 1/2 inch. So instead of being the spline here, it would be here. The spline is where the wheel connects. And then the turning radius for that robot is a little bit wider. It does not turn as well. So I like to mount the motors with the wheels closer to the middle of the robot, kind of like a Roomba. There's a reason a Roomba is designed that way. It turns very well. When you do this, the potentiometer, which is a little dial that's on the motors, cannot be reached as easily because the battery pack is in the way. So we'll take a screwdriver and we will adjust these motors, center them before we actually build the robot. And you can do this following our instructions too. However, the instructions have you building the robot first and then turning the potentiometer with the screwdriver to center the servos. I like to get this done in advance. So most people who've used a lot of parallax stuff are like intimately familiar with this little detail, and it becomes a no big deal after a while. So I have taken this circuit, the microbit, and I have mounted it onto my Cyberbot board. Try to get that in the display better. All right, and I am now going to center my servos, and then I'm gonna have you build it and then center yours, and after that we're just off to, in fact, if you want to go ahead and start assembling it, you can do that right now. You definitely want to use the right parts. The page where the assembly instructions are on, I will take you there right now. It's on Build Your Cyberbot and then connect the microbit. And it looks like this. So you're going to need 2 acorn nuts, 2 440 nylon hex nuts, and then a couple of flathead screws. And when you assemble this, the order of operation goes like this. So you put the screw through what would be the top side of the microbit, and then you'll tighten down this little threaded nylon nut. And that will center the screw on the hole of the microbit and allow it to line up with our Cyberbot board.
So the nut goes on the same side as the LED display.
Thank you. Yeah, here's a little better picture of it. And you can hand tighten that too. You don't have to have any tools. And after you put that screw and that nut through the microbit, then you'll attach it to the CyberBot board.
Hey, Ken, it's
Yes.
Erica again. I'm having a little trouble getting this thing put together.
No
I'm
worries.
spatially challenged.
Show us what you've got here. Put it in front of your
Uh,
camera.
I've got pretty much nothing right now. I can't
Okay.
even find the right parts.
That's all right. So they are in a couple of bags. One bag had, I think the black acorn nuts were in a separate bag from the white threaded nylon nuts. But it's okay if you don't get it right now.
They should be in the same bag.
The same bag in your case? Okay.
I found them in the same bag.
Yes.
Oh, good. All right, and you will need your parallax screwdriver for this. You should have one of these in your kits.
Yeah.
So I would advise then for all of you to pull up this page that has the assembly on it. And while you do that, I'll get together some code to center the servos.
I put the link in the chat pane.
Oh, awesome. Yeah, so y'all see the chat there? Stephanie put that link, and you can just click on that and then go straight to the assembly. Is everyone having fun so far? Everybody's busy at work.
I'm also going to post the connect and power the servos part. So a page that shows the correct orientation for those servo cables. Since we have that question. No, we don't have to build the entire CyberBot now.
No. So you'll just wind up, my hope is to get you to the stage that I'm at with this picture. My pinned video right now has 2 motors connected to the CyberBot board and a battery pack and a cable. That's the stage I'd hope to get you to. And we're doing okay on time.
And yes, Matt, only 1 nylon nut per flathead screw. We want the 2 boards, the microbit and the CyberBot board, to be separated just by the thickness of the nylon hex nut.
Where did you find the acorn nuts?
The acorn nut should be in the same bag as in a little tiny, about 1 inch square Ziploc bag, along with the 2 nylon nuts, 2 acorn hex nuts, and the 2 flathead screws.
I have one bag that's got a whole bunch of screws in it, but it doesn't have the acorn nuts.
Yeah, look for a separate small bag.
There's another bag?
It's just a little Ziploc that has just those few pieces. The larger bag is for assembling the robot.
Okay, hang on. I'm gonna find it. It's here someplace. Good. I'll know exactly how my students are gonna feel.
Yeah, that's the idea.
It may be in the very bottom of the box.
I pretty much emptied the box, but let's try it again.
So while we're on this subject and you're all building away, most teachers opt to have the students fully disassemble the robots at the end of a semester. So one thing I'll tell you, and have really methodical parts management. So a trip to Walmart to get a Plano box or two for storing components is a good idea. And they do not allow the students to put the components, and I'm talking about the electronic components, loosely into the box with the robot. They pretty much manage them at the front of the class and have them return them. One thing that's unique about the Cyberbot is the circuit building is simple enough that you can build them and then dismantle between classes without losing a lot of work.
I honestly do not see that.
Actually, let's see if I can show you what they look like. So mine are installed on my board. Let me get my video.
It's a really, really small bag, about the size of a postage stamp.
Let me pin that video, Craig, that you're showing. Okay, so you should be able to see Craig's picture right now. He has a small bag that has 2 acorn nuts, 4 nylon lock nuts, and 2 flathead screws.
Where is it? I don't. Where's his picture? The bag.
So you'll have to go to your video gallery view somewhere and zoom.
I'm also posting the link of what this hardware looks like, because this little baggie of hardware is available separately in our web store. Oh, and Annie says, check in the bag with the wheels.
That's helpful, Craig.
How far are we getting on this, Bill? How far do we go?
Okay, so you can assemble the microbit right onto the Cyberbot board now, and then get out some batteries, plug them into the battery pack, and then find 2 servo motors. Those are going to be a lot easier to find.
Are these double A's or triple A's? Oh, double A's. Okay. Hold on.
Double A's.
That little bag was not in the bag with the wheels.
Did you find the little bag?
No, I did not. It's not in the bag with the wheels.
So you still can't find the parts, right?
I still can't find the parts.
Okay, it's possible you didn't get the parts. So that's okay. We'll get those to you. Stephanie will.
Yep, I'm on it.
Okay. Well, heck, we only have 70 teachers building something right now. What could go wrong?
And some are saying that the bag was separate at the bottom of the box.
Yeah, I emptied completely emptied the box.
We will send you another set, and at that point it will appear where it had fallen between things, because I can never find something until I replace it.
Oh, always.
So as some of you get this Cyberbot mounted onto the microbit, mounted on the Cyberbot board, maybe you can kind of show that up on the screen. Oh, cool. I'm seeing some video now. Okay, good. So yeah, Annie, Neil, William, Nicole, you guys are doing great. Oh, Amy's like, hey, I'm already rolling here. Okay. John's got it. Okay, so you can plug in some batteries to the battery pack, and then find your 2 servo motors, and we will plug them into the Cyberbot board. And then we will be centering our servos.
Who is it who's missing the screws?
Erica.
Erica. It is Erica Roberts. Okay.
I've got her shipping address. Yes. If anybody else is missing something, don't hesitate. It's unusual that we leave things out, but it happens.
Then we're 18 and 19, is that correct?
Yeah, 18 and 19. And when you plug the servos in, the white lead on the servo goes closest to the P18 and P19 silk screen. That's what we call it on the Cyberbot board. So the white servo lead goes next to the white silk screen, P18, P19. And once you've got that, you can go ahead and type in the code that I have on my Python editor. And then you can flash that code, and you're going to be using the new library. All right. So Tim, looks like you're doing great. So once you run this code that centers the servos, it gives them a signal which basically should hold the servo still, and it won't, it'll turn. So what you'll do is you'll take your screwdriver, like I'm doing here, and you will gently put it into the what we call potentiometer. It's a little dial on the back of the servo, and you will turn it until the servo stops. So I just centered one of them. Now, of course, you have to have this code flashed to your microbit first, which means the Cyberbot library has to be on the microbit, and your code, your script, correct terminology, should look like my script.
So
Hey,
Ken,
Ken.
is it safe to say that I can't do anything until I get those parts, and I'll just work from the tutorial?
Yeah, it's probably the case. In fact, we should probably
Okay.
scour your desk a little bit. I'm hoping they show up.
Yeah, well, my colleague just sent me a picture what the bag looks like, and I
Definitely don't
did
have
not
it.
see that. Yeah.
What's your location, Erica? Are you East Coast?
Chicago.
Chicago, yeah.
Hot spot of the world.
Yeah, we're going to have to get these to you quickly, but we can get them out today.
Okay, thank you. I
Yeah, and
appreciate
so
it.
you bet. And so sorry that happened. So while we're all here at this stage where parts can be left out sometimes, we have an educator hotline at Parallax. It's apparent throughout our website, 916-701-8625. If you ever have any problem with our hardware, using it or with components, dial that number. I will answer the call and get you what you need. We never want you to be stuck due to lack of parts. So sometimes we don't mess around with school purchase orders. We just want to get your parts replaced. I don't want your students stuck.
We have some questions coming in the chat pane. Oh
Yeah,
yes,
I'll
put the phone
Thanks,
number
Stephanie.
in the chat, but there's about the power settings.
Okay,
if your
power
servos
settings.
aren't moving, all that.
Okay, so the process of centering the servos goes like this. All right, so I have typed in some new code here, and you notice it says I'm using this bot. All right, bot refers to a function in the Cyberbot library. It's a method call, actually. And bot18.servospeed sends a centering pulse to the servos and actually maintains it. If you're familiar with the BoBot and our other products, this pulse is maintained once you set it. So it's a set it and forget it speed, which makes coding very easy for the student. I did this code for pin 18 and pin 19, and then I flashed it. And at this point, I switched my Cyberbot board to position 2. You'll notice there's a 3-position switch on it. Position 0 is off, and when it's off, the microbit can still be programmed because it's powered by USB. But when it's in 1, everything is powered but the motors. And when it's in 2, the motors are also powered. So once you flash this code, you have to put this in position 2 to see your motors turn. And they should just be turning a little bit, maybe like this. But you'll take that screwdriver at this stage and you'll put it into the hole on the side of the servo case and gently turn. This is a plastic potentiometer. You don't want to wrench on it. Just gently turn that potentiometer until the motor stops. And do that for both of them. And if your motors weren't turning, it was probably because you don't have the battery pack connected and you don't have the switch in position 2, or you didn't download the code. See, there's a lot of fun stuff here, isn't there? I'll be looking for some visual feedback from you all here. Maybe show me kind of what you guys have got. Jackie, you succeeded? Ah, yeah, all right. Matt, did you succeed? And Cheryl, you're still working, right? Okay, I'm reading your lips.
Yeah, Elaine, it is a little touchy. You go a little too far and then little too far the other way, and then all of a sudden it stops. Oh, so James Welsh has servos that are not working at all. Can we look at the jumper, the power jumper? 2 people. have servos that are not moving at all?
I'm willing to bet that they're either plugged in backwards or they don't have the battery pack plugged in. So for those that don't have servos that are working, let's make sure, first off, you've flashed the code on my screen that you've typed. Second, that your servos are plugged in like so, so that the white lead is next to the P18 and P19 silk screen. This is also in that picture I sent you by email. And then third, that the switch is in position 2. Fourth, you have a battery pack connected, and that battery pack jack is plugged into the board right here. And
the
then I've
batteries
lost.
are the right way in the battery pack?
Yeah, the battery's the right way. It's always a fun test to see if things are hot. Then you'll find out. Yep.
So I'm using nickel metal hydride batteries. Does it matter if you switch that jumper pin, on the next thing over? Or
Yeah, you can put it on VN if those output a little lower voltage.
Okay, and then I had to reflash reload the cyberbot.py library, and then it reflash it, and then it worked. I think
okay, that's interesting.
The same issue.
Good, great tip.
Ken, this is Gene. I still have a problem with the extracting the cyberbot files. So I don't have flash on my microbit on my screen here. So mechanically, I got everything okay. I used the Bobot, but I'm going to have to go back. I'm one of those people that didn't do my homework.
Yeah, no worries. You've seen it. So that's a big benefit, and the tutorials show you as well. So everyone's got that working more or less then? No? Okay. Joan, give us an idea what you're facing.
I got it. I'm not sure about how to flash it.
Oh, okay. Let's go do that together. All right. So make sure first your code looks like mine.
Yep.
All right. And for kicks, let's make sure you have the CyberBot module on the microbit. To do that, click on Load, and then scroll down to where it says Show Files, and you should see that you have the cyberbot.py there.
Where was that file that you pointed? Oh, load. Okay.
Yeah, I'll minimize her.
Right, and then what do I do?
Okay, do you see cyberbot.py on your, use that code module? Okay,
yep.
Perfect. Close this. Now type code that I have. So this code is really just 3 lines from CyberBot. Okay, you got it? Okay.
Yeah.
All right, perfect. And then to flash it, do you see the flash button on the upper left? And does it say flash or does it say download?
My motors are now all of a sudden turning.
Okay, it sounds like you're on your way.
Yeah, don't know what I did.
Ken, this is Gene again. I'm the one that doesn't have flash. Mine still says download. But I
okay, so Gene,
the Cyber P is in the load.
Okay,
file.
that's no problem. So in your case, your browser window now looks like mine. Okay, so I disconnected. I will download, and it's going to make a hex file, and it's going to save it.
Okay, hang on just a second. I'm going to make a hex file.
Yep, so when you click on download, it will download a file to your computer, which you will then drag onto the microbit.
Okay, so it says CyberBot hex, so I just want to click save file.
Yep.
Okay.
And then you want to drag that onto the microbit. So go open a, go to your desktop, like I'm doing, and I'm going to find the file that I just downloaded, the hex, and I'm going to drag it onto the microbit, and then that will run.
So I got to find that guy and drag him onto the micro.
Yeah, and one thing that that a lot of people do, that Andy will do, he's here with us, is he'll set up an Explorer window side by side, or he'll just drag it straight from the Chrome download.
Okay,
bar.
again, I'm using Firefox, so it's not
Oh, okay,
exactly-
yeah. So between now and Wednesday,
Okay,
get Chrome on there.
I'll do
We'll
that.
have a lot
And,
more
and
fun.
then I'll go back through your tutorials. I know what it is that I'm missing.
Yeah, it's provided you've seen these steps, and then you know kind of the gotchas, and you're on your way.
Okay, I can do that.
Hey,
So
can we have Andy take a look at the questions that Sheeta put into the chat?
Yep,
She says,
go ahead, Andy.
I see the Cyberbot file, but I get traceback most recent call last. Huh. Name error, name bot is not defined. That
Okay,
sounds like
that's
the Cyberbot.
modules missing.
The module's missing, but if you see the Cyberbot file on your microbit.
Looks like you guys didn't need me after all. That's right. You'll want to go through the steps again to get the Cyberbot module into your browser. Ken is hitting load save. And then going to explore and dragging and dropping into the or browse for a file.
Could it be that it's not unzipped?
It definitely has to be unzipped,
Likely,
otherwise
yeah.
it won't find it.
So if you downloaded the Cyberbot file that Ken pointed you to, it would need to be right-clicked and extracted.
Sorry, it is zipped. What happens is I get one slight movement and then it doesn't move.
You mean the robot?
Yeah, these
Oh.
two. Just give me, they give
Okay.
me one little, one degree angle move and then.
Okay, so right now, could you put your
Batteries.
screwdriver batteries, you think, Andy?
Well, batteries
battery.
and switch to position 2, but mainly batteries.
Oh,
She
here, I can
show us your whole
demonstrate
setup.
to you. Oh, battery. Okay, my battery. All right, here.
Okay, do you have batteries plugged into the battery pack?
Yes, I have.
Let's see, pick it up and put it in front of your camera.
Yes.
See something here. Yeah, it's
Okay.
tricky.
Do you see
Okay.
it? Okay.
Yeah, and then show us,
Did you see it?
yeah, see that. And then show us how the battery pack is plugged into the board too.
Okay.
Also check to make sure the cables are plugged in directly. The white
Okay.
wire and they needs
Yeah,
to be.
looks right. And then your battery pack, are your batteries firmly pressed in? Is your switch? The switch on the board, is it in position 2 on the Cyberbot board?
Yes, yeah, and when I put it on 2, you get that small movement. So I put it back on 0 to show you. Did you see a small
Yeah.
movement?
Okay, so put it on 2,
Okay.
and then go ahead and see if you can turn that potentiometer if the servos do begin to turn.
I tried that. They don't.
Reload the code.
Okay.
Yeah, let's reload the code. Okay, so getting a visual on the others. Need to get a thumbs up or thumbs down just in general to see kind of where everybody is. Okay. A few more thumbs up, thumbs down here. Okay. And when there's no thumb or someone scratching their forehead, that might mean to me you don't have it. So we'll need to help you there. So like Annie, did you succeed there? Annie Murray, give me a thumbs up. Okay. Neil, did you get it too? Okay, that's good.
Potentiometers are inside the servos, and that's what you're adjusting when you're turning that screw slightly.
Michael Knight, you got it?
When you say slightly, how much do you mean? Can you?
Eighth of an inch.
Oh my gosh.
Yeah. Yeah, don't treat it like a screw. Potentiometers might only turn 1 full rotation or less.
Oh, because I kind of turned it till it stopped.
Okay, so those of us who've got it, we're a little bit over, but it's okay. 9:20 here in California. You are ready to build your Cyberbot. All right? And the instructions are in the tutorials. And this means that you'll spend about an hour and a half. I want you to do a really good job. I'm going to give you some assembly tips on what a good build looks like. Let me find one that's actually a good build. That might be the biggest challenge. We have intern built, and then we have Andy and Stephanie and Ken built, and they're all different, right? So a good assembly might have the wires, scooch things back a little bit, give you a better look at that. We'll have the wires going underneath the board so they can't get tangled with the wheels, all right?
Can you make that full screen, Ken?
Sure, let's do that. I'll do a pin. Does that help? How's that?
I'm still seeing your microbot screen.
Oh, okay. Oh, I see.
It
All
might
right.
help people see. I mean, that's
yeah, let's try this.
an eye chart.
I had to click the little button, then swap share. I can't speak. Swap shared screen, and then it allowed me to see it.
Okay, just a minute. Let's see if I could do that. Tell me if this helps you. Not that camera. How about
well, we're seeing you now, but it's bouncing back and forth.
Funny, yes. The other. All right, you have a video of my robot now, right? With me.
Got it.
Okay. All right. So the things I would pay attention to when assembling this are that the servo wires go off the side of the board and then right underneath it when you build it. You do not want them to be in the way of the wheels. So you see mine is pretty tight against the board. Turning the robot over, and you'll notice too that all the wires go through the middle. There's a grommet and a hole. I've tucked the wires into the middle of the chassis tightly. And then I've used lock nuts. You will find in your kit that there are lock nuts which have nylon inserts in them, and then there are threaded machine nuts which have no nylon. It's much easier to assemble it with the threaded machine nuts, but I prefer the nylon lock nuts because things will not vibrate loose. So use the nylocks. There's a little plastic wrench in your kit you'll find for this process, and then just tuck all the wires in there so they're not dragging on the ground. And finally, there are two ways to put these motors in, as I mentioned earlier. There is the way I've installed them, which would be like this, okay? That's the preferred way. Or you can turn them over, and then the wheels are more forward on the robot. But I prefer to do it this way. You will too. Is that all good? Okay. So next class, we will be moving into coding the robot. And for those that are still having trouble right here, I can stay on for another 10, 15 minutes and give you a hand.
I just want to make sure that I've done the potentiometer correctly.
Okay. Tell me how you did it and
I
talk it through.
Inserted this in there and I turned it until it stopped.
Mm-hmm. So one thing about turning it until it stopped, if you turn it a little bit one direction, it should start turning one direction. If you turn it a little bit the other direction, it should start turning the other direction. If you ended up turning it all the way to the end of its range of motion, it might also stop, but you won't necessarily see that behavior. So test that. Make sure you can turn it a little bit one way, turns a little bit counterclockwise, and turn it a little bit the other way. It'll turn a little bit clockwise. Then go back and re-get it to the middle where it stays still.
I'm sure that what you just said made sense, but to me, I heard turn it. So if I think I have to download it again every time that I switch off to zero on the on this whoops, on this part here, every time I do that, I have to go back again and re-flash the program. That's
well, no, normally, if you flashed it once, when you set the switch to 0 and then back to 2, the same program should come back for you.
Okay, so I just reflashed it, and now I'm going to press it to 0, and so everything stopped.
Okay.
Okay, because I wanted to do the thing with the screwdriver, which
Joan, leave it in position 2. I heard your servos turning when you had it in position 2.
Okay, so now I'm going to put it back to 2.
Yep, and leave it there.
And it's not moving.
Okay, so try flashing it again. That's interesting.
I know.
Not seen that.
Hello, it's me.
Okay, so leave. Okay, so that looks good. Keep it in 2. That servo's turning. So now is the time when you want to try putting the screwdriver in there in that little hole, and then gently twist the screwdriver until you've tried twisting it back and forth. And at some point you should find a spot where the servo stops turning.
Okay, it's definitely slowing.
Good.
It seems to be, I want to go this way. Nope, I want to go that way.
That's exactly where you want to be. Yeah.
That's where I need to be.
And one of mine adjusted way easier than the other. Like one of them I could quickly stop, and the other it took me a really, really long time.
And very really touchy, like it's almost even if you press it a little bit and then drop off on the pressure. Yes. So it takes a few tries, but you'll get there, within a minute or two, you'll have it just right. And
I was excited when they moved. That was the goal.
All right. Okay, so one done.
Good job.
So I missed the whole thing on how to assemble the stupid thing because I was trying to get the thing to stop spinning.
No worries.
I thought getting it to spin was the objective. I was so excited it was spinning. Oh, well. I blame Chuck.
Yes! I have success. All right. So now am I ready to go ahead and build the robot?
Did you do both servos?
Yes.
Perfect. You are ready to start building the robot. Absolutely.
Thank you very much. See you tomorrow then.
Yeah,
all right,
sounds good.
Can you help me?
Yep, we can help you.
Okay, so I think there's something wrong with let me see if your camera can get that. I think there is something wrong with the cables. So basically I was able to go to the serial mode and import the module and then put bots dots blah blah, and I didn't get the error. So it doesn't look like with the CyberBot not loading. I think there's something going on with one or both of these. So here's the experiment. I take those out, and then doesn't matter which one I put it in, right?
P18 and P19.
Yeah, I know, but it doesn't matter which one.
It does. Yeah.
Oh, it does. So maybe that's why.
No, I think you actually had it right. So the white cable goes closest to the white label on the CyberBot board.
Right, I understand that part, but it doesn't matter which one of these I plug with, right?
No, does not.
All right, so let's try this one, and we can just see if that one of them works.
Okay.
But did you see I saw?
I did.
Now, if I try to,
I think I see the problem. I think that first AA battery is popping out of your holder, but I'm not really sure. That one.
This one?
Yeah. Was that loose?
I don't know.
Okay. Maybe you're okay there. And all those batteries are inserted properly.
Yeah.
Okay, I'm looking. Yeah, so press them all in, and then that battery pack is plugged in.
So I had, in some cases, I was able to press a little bit force here, and this started moving.
So let's do this, Sheeta. Take your screwdriver and gently turn the potentiometer on the servo with the Phillips side, the other side. Yeah, and let's just see if the motor starts turning. Okay, so I'd say your motor's not getting a signal, but all right, let's verify a few more things. Your 3-position switch on the board is in 2, right? Yes.
Yes.
Okay, and have you actually downloaded the code?
Yes, I can share my screen and you see I have that.
Let's yeah, share your screen with us.
Oh, it says I cannot start sharing.
Maybe I have to enable that. Let's see if I have that ability.
I think you would have to stop sharing in order to have someone start.
Oh, there you go. Yep, that one.
Okay, and I think
there you go.
Stopped, so maybe she can share now.
Okay, so I show you my file.
Okay.
I did go back and unzipped again and load it again and so on and so forth.
All right, close, go up to the top and then X on this. And let's look at your code. Oh, okay, here's the problem. So from microbit, that should be from Cyberbot import star. So replace the microbit.
Sure. I'm sorry.
It's okay. This is why we're doing this. This is what we're here to do. And then, okay, now you're going to have it working. So now flash it again.
Okay, I'm just going to make sure I have this.
So this is really important for your students. They'll do the same thing. And this is just real engineering stuff that our engineers have to deal with when they're designing products. It's the same kind of thing.
Yeah, I worked in a chip company for 8 years and built prototypes. So this is really cool. There. So
okay.
Hey, all right.
Now show us your servos turning. Let's look at them.
That's right. Sorry.
Pick it up. Yeah, or point your camera down or something so we could see the motors.
Oh, I have to get out of share, right? Or no?
Okay, that's fine. Now, take a screwdriver while we're watching you. This is good. And then slowly turn that potentiometer. Just doesn't take much of a turn, like a quarter of a turn. Oh, so you went too far. But you've got it. Yeah, clear that cable out of the way. And now you have to use yes, almost right. You're on the way.
Okay, already. I just stop it and then start building.
Yeah. So before you're done, Sheeta, make sure that first motor's not turning, okay?
Okay. So it looks like there is this one place here that it doesn't stop.
It'll stop. You just have to have a really gentle hand. And this is something like a physician might be able to do this really well. It's about haptics. You have to feel that pressure. See how you did that? But that came kind of suddenly. Okay. Is anybody else having similar type problems, or are we
I have a list of people who've been having issues. Some go back to simply getting the microbit to be recognized by the computer. And then some are up with the servos. So, go for it.
My servos only move when I complete the circuit with my finger underneath the board.
That sounds like your microbit and your Cyberbot board need to be connected tighter together. So it could be that the little hex nuts need to be screwed closer to the microbit and then the acorn nuts tightened.
Is that a try? And you can help someone else.
Yeah, unplug power before you do that.
Don't want to electrocute myself.
You only got
I think there's more harm to the board than to your person. But
anybody else while she's doing that? So tighten down those acorn nuts, and
the hex nuts have to be tightened enough as well.
Hex nuts first.
Yeah.
Thank you very much for helping me.
You're so welcome, Sheeta. You're doing great.
Thank you.
Okay, and let's see.
Who else needs some help out there? Go ahead. Throw your questions at us.
Anna Rodriguez was having difficulty getting the microbit to be recognized. who do we have here?
Might be, the only thing I can think of there is try a different USB port on the computer, try another cable. Try
I've already done that in that. I've tried 2 other computers and 2 other Chromebooks.
Oh, wow. Okay.
Oh, no.
And a different USB ports and a different USB cable.
You have all kinds of hardware. Okay.
Wow.
So you were never able to connect the microbit then successfully?
No, it lights up red. Like it goes through like the press A, press B thing when I plug it in. So it has power. It's just it doesn't show up on my computer as like a device.
It doesn't show up at all on the computer. And if you hold down the reset button on it and then you plug it in, so the reset button is
this one.
It's right next to the USB port. If you press that button down and then you plug it into your computer, does it show up in maintenance mode?
I tried that yesterday. It didn't. I can try again. I hold maintenance.
We might be sending you a microbit today.
It's very rare, but that could be it.
Files open. You see how it lights up red?
Oh,
but then like,
yeah,
there's no yellow. Do you know what I mean? So it goes through like all that, but then on my computer, it doesn't show that there's anything been connected.
So Anna, what you want to do is press and hold that reset button and keep holding it. Then unplug first. Unplug USB from the computer. Then press that reset button and keep holding it while you plug it into the computer. And then count to 3 or 4. Let's make it 10, and then let go.
So while I hold it, okay, so I have the reset button pressed.
And you're holding it, so then plug in,
I'm
count to
holding
10, then let go.
Okay.
It's kind of tricky, a little bit of dexterity to do this, okay? So what Andy's describing, I press the button.
So that's a funny thing. We can see actually that it looks like her, the microbit did not do what it was supposed to while she was holding the reset. It instead is running its little default program.
Yeah, it goes to A, B, yeah.
Yeah, so what kind of computer have you got?
Well, right now I have it plugged into just like a Chromebook.
A Chromebook, okay.
And then I've tried my actual like computer that runs Windows 10 and it does the same thing. And then another computer that has Windows 10 and does the same thing.
And she even swapped out cables.
Yeah, all right. Gosh.
I would say faulty microbit.
It seems that way. So you open the Windows Explorer and the Chrome file browser, and there's no microbit showing up on the left-hand side. Let's see if I can see you here.
I don't know if you can see that or not. Hold on.
Okay,
So
that's pretty amazing.
It'd be like right here, right?
Yeah, I've got you in thumbnail view. I'm trying to.
Yeah, I don't know how to make it.
No, it was me. I got you now.
I just pinned her video.
Yeah. Oh, okay. So, yeah, I don't see the microbit either. Okay, yeah. I think based on all this, what Ken and Stephanie say about your microbit potentially being a defective one seems possible.
Where are you located?
Oklahoma City.
Yeah, I was just thinking, where to get a microbit in Oklahoma City? I think we're going to be sending you one. So could you chat to Stephanie
I'm getting it right now. So so I'm talking to Anna Rodriguez.
Yeah, and her data, her shipping is all in the spreadsheet as well.
Thank you for your help. I tried a ton of tutorials yesterday and I couldn't.
Oh, I'm so sorry. I mean, bad hardware sneaks through. We don't test these. We get them in a box and ship them out, and counting on them to do that factory. Sorry, you got caught in that trap. Anybody else have any gotchas going here?
This is Cheryl. I couldn't get mine to ever do the connect either. I could download to it directly, but never the connect.
Oh, you mean that you could make a hex file and then drag it onto the microbit? Okay, so what you have to do is the following. Look over to, let me make sure I have a share going here. All right, I'm going to share how to upgrade your microbit firmware. So if you go to Google, type in upgrade microbit firmware, and it's the first link you will encounter. Looks like this. And all you do is you download this latest firmware, and then you you hold the button down on your microbit, you plug it in, then it goes in maintenance mode, then you drag that firmware file onto the microbit. And then your microbit should be able to connect directly in Flash. I'm going to post this into chat so you can go straight here. So technically what happened is microbit, or the Python editor people, made a release that depends on a certain microbit firmware. And because we got our microbits a long time ago and then the software is upgraded, the two are not perfectly compatible.
Okay.
Did you see the link I posted?
Yes, so I'm in maintenance and I've downloaded the file.
Okay, and then hold down, make note of where you saved it, and then you will unplug your microbit from your computer, hold down the reset button on the microbit, plug it in, and then release the reset button, and it will show up as maintenance. And at that point, you'll drag that firmware file onto the microbit maintenance drive. And then I'm willing to bet it shows up with Flash. You can connect and Flash to it. While you do that, we'll check who else out there is stuck. Stephanie Fraser, you got it okay?
No, it's still only when I put my fingers here, they spin.
Oh, okay, show that again. Put that up again.
Sorry, they started moving.
Let me just enlarge that video just for a minute.
Can you show us the top of the board and see if there's a little jumper that should be connected to some pins?
Oh, I see the problem. See that red light? It's a good learning moment. That's our low battery indicator.
I just put these brand new batteries in. Just a second. Let me put brand new batteries in.
Huh, that's peculiar. Okay, so if
giant box here. So.
Brand new batteries are not the problem, you might have an issue with the board.
What does the low battery indicator look like?
Flashing red light by the servo ports. There's a little triangle with an eye in the middle, and there's an LED mounted underneath the board that shines through the board. Do you see it?
Got it.
Yeah, so if you have some dead batteries, try it out. It's a new feature on our robots.
While she's working on that, I have a quick question. Yeah. For the hex nuts, the ones that have the stuff on the inside, does it matter which way that bolt goes, the nut goes?
Oh, when you're assembling the robot, you want, and you're using the nuts that have the little nylon insert.
Yes.
Yeah, the flat part of that nut goes goes towards the screw, and the little domed part goes the other direction.
Okay, thank you.
No problem.
Stephanie, how did it go?
I replaced the batteries. The indicator did stop flashing, but it still is only turning when I put my finger underneath.
Okay, show us
the soldered part.
Put your board up to the camera so we can get a look at how the microbit's connected to it. And then turn it sideways a little bit. And then give us a side profile view.
That way?
Yeah. It's funny on my side, I'm turning my head. It doesn't change how you're holding it. Okay, so you have your little sandwich looks like this. You have the microbit, a screw goes through it, and then you have a nylon nut, and that nylon nut is tightened against the screw. And then the microbit plus the screws and the nylon nuts go through the board, and then you have two black plastic cap screws on top.
Yep.
So you built it right.
Can we check for a jumper on the power pins next to the servo port? There should be a little jumper there that will allow power to get to the port. I'm wondering if she's bridging that with
Great
her
point.
finger.
Here, I'll give her a visual on that.
Yeah. It's also on this page. We'll show you.
Okay, so on this, I don't know if you could see that okay.
Yeah.
Do you have a jumper, and that's a little black plastic part that is plugged in next to the P18 and P19. You should have this little piece here.
I chatted
that.
Piece.
It's
plugged in there.
Yeah, I chatted an illustration too.
Okay.
Yeah, it's on the VIN.
Are you using alkaline batteries?
Yes.
Yeah. It could be on the 5-volt or the VIN.
And what you're experiencing is the motor's only turning when you're pressing the board.
Soldered board, yeah.
Can you unplug the battery pack, pull that jumper off, and then try connecting it to the 5-volt according to the picture I just sent to you in chat?
Yeah. Oh, my robot is typing on the keyboard. Okay.
We could also try moving over to pin 16 and 17.
Yeah, that's a good idea. And then if you do that, change your code, Stephanie, to use
16 and 17.
Yeah. That might be the issue.
So another thing to try also is the little tab that they've been showing you that is plugged in closer to 5V. If you unplug that and it just comes off with absolutely no sense of resistance, and you put it back on and there's not really a sense of resistance either, those lower two of the 3 pins can be pried apart slightly, so that when you put the sleeve back over them, you'll get a little bit of resistance, and it'll make its electrical connection and hold it.
Nicely described.
Not making contact. Yeah.
That's good.
Right now, plugged into pin 18 and 19 don't work, so let me try moving them over.
16 and 17.
18 and 19 won't work until you update the program to make the servos go on 18 and 19.
They already were 18 and 19. I have to switch them to...
It defaults to that.
Okay.
And let's make sure, too, you do have the Cyberbot import.
Yes.
The first line, okay.
She could get him moving when she was shorting out the power from underneath. So I think the power is just not getting to the servo ports.
And Cheryl, did you fix the problem there with the firmware upgrade? Oh, right on. It's great.
By the way, what part of the underside of the board were you touching to make the servos go?
Right below the 18, 19 pins.
Okay.
So I think she was becoming a shunt jumper.
Yeah, I think what Andy said is probably right too. She was shorting maybe power with her finger, but maybe that jumper was a little bit loose in there, and just spreading those 2 posts a tad will tighten it up. So it will be interesting to see if we have the same problem on 16 and 17 with our board.
I do have the same problem there.
Huh.
Okay. So we build some servo ports on the breadboard?
Let's try one servo first.
Okay.
I'm curious if she presses the jumper. So she said she was touching the bottom of the board. What about just pressing that jumper a little bit sideways? Does that make the motors turn?
No.
Okay.
16 and 17 do it when I put my finger underneath.
And you're definitely in power position 2.
Yes.
Okay.
There's a bad ground connection somewhere. It might actually be on the board. If you loosen the acorn nuts, turn off power, loosen the acorn nuts a little bit, and just make sure that the board is seated. Just wiggle it slightly and find the sort of where it wants to be in a center position, and then retighten the acorn nuts. Try that.
Good one. Yeah.
Yeah, I mean, this is behaving. Yeah, I don't really know of a good way to describe this, but it's behaving like it can't find the common ground problem. So there could be yeah. Okay. So what Stephanie said about building your own servo ports is probably another thing to try.
Wiggled and retightened. Complete. Power.
And one thing you could do, turn that board over and then look where the little machine screws go through the board and make sure that the first set of contacts is pretty much lined up with the little gold pads. I'm just checking to see maybe if your board is shifted over a little bit, but it sounds like it's centered for you.
Yeah, they don't feel like they could.
Like there's nowhere else to go but only one way. Yeah.
Line up as much as it can.
This is kind of what I was looking at. See those the first 4 contacts? They should be right under the plated.
I actually only see the code.
Oh, okay. Sorry. Here we go. Zoom usage.
Okay.
Okay,
Yep.
So I'm talking about right here.
Yeah, that's what mine looked like.
Looks the same.
Overlapping a few millimeters.
Yeah, one thing. Yeah, we might be sending you another board. Where are you located?
San Antonio.
I'm sending the request now.
That's why there are 3 of us here.
I may be able to get, I know that my district has some of these. I may be able to borrow one if I can get someone that will
surrender it
into the IT department. In the meantime.
I don't know what will be faster. We could have a contest and see what's faster.
Probably faster for you to send it.
So I think we've concluded you may have a bad board.
Awesome.
That's
but I feel like we've solved as much as we can.
You did great troubleshooting, actually. You're ready to instruct with this.
That's right. I feel like we've encountered all the errors, so my students are ready.
We haven't seen Python syntax errors yet.
Oh, I got that covered.
Oh, good. Is anybody else having trouble? James, looks like you're just moving along fine. Okay, I can read lips. So now it's just
Fraser, can you I couldn't quite see. Can you hold up your board again? I have you full size on my screen now so I can see what you've got. Okay, so yeah, and then let's look at where the servo. Okay, so you've disconnected your servo already.
I can plug them back in if you want.
Yeah, so the other thing to try, although it's not something we normally recommend, is on the 18, let's see, is it 1819 ports?
Right.
Okay, so there's a little jumper to the left of them, a little tab that's sticking up. let's unplug that and then plug it in over the V-in. We don't normally do that because it's technically not the right voltage for the servos.
So
but,
like the.
Yes. Let's see. Okay, you can see it, Stephanie. I can't, but
all right,
okay.
someone can. Okay.
So let's go ahead and just try that and see if your servos turn with it plugged in that way, and then we'll so just connect the batteries briefly and let's see if they turn without any.
We did try that, and it only works when my finger's underneath touching the soldered components.
I apologize. Okay,
That's okay.
I couldn't see you.
Hey, by the way, on those soldered components, as you look at those pads underneath the board, can you tell that they're fully soldered or not?
They are really small.
Yeah.
They look better than I could solder. They look complete though.
One thing you could do is just, in the meantime, heat that up with the soldering iron just to see.
I knew I had it for a reason. Yes,
Yeah.
I will try that in the meantime, see if it works.
Void your warranty, so you own it.
Don't tell the people who made these, okay?
Right.
Make sure to put that tab back over the 5-volt setting.
Stephanie, Stephanie Lindsay, we had a total of 3 hardware issues, I think.
Yes.
Were you able to capture those?
Yes, they were
Okay.
captured, and requests for replacements for all have been sent, and I know at least the screws already went out. I have not heard back on my request for the microbit board going out and the Cyberbot board going out, but all 3 have been
Good
made.
stuff. Jackie, show us your robot up to the camera here. All right, it's going together nicely. Good job.
Well, there we go.
And Corey, how are you doing there? Oh, okay, moving right along. And Jack Henderson, also? The rest of them have video off. Okay, good, thumbs up, all right. Okay. All right, so I think nobody else has real issues except for microbit not being found, one bad board, and there was something missing nylon nuts. Okay. 70 people, 3 little problems. And Sheeta, you're okay now? You're on your way?
Yes, I just missed your instructions about how to put the
Servos together. Okay. All right. So it's just a preference that I have. I'll show you right now on video.
Okay. Thank you.
You bet.
I lost your video. Where are you?
So it should be back now. Do you see it?
Yes.
Okay. And so the point I was making was that I want you to note that the servo has an axle basically here, right? There are 2 ways you can install the motors on the robots now that you've centered your servos. One way is the way I have done it, which is the preferred way. Okay, so in this case, the axle is closest to the battery pack. The other way is that you take that motor and you flip it over, and then you install it with the axle closer to the front of the robot.
Yeah.
Follow me?
Yes.
Okay, so I think this way is better. Both ways work.
Okay.
And the benefit of having the wheels closer to the center is you have a tighter turning radius, and it will run better on a variety of surfaces.
Got it. Thank you so much.
Yeah, you're very welcome. Anybody else have any other questions? Okay, because
A question that came across several times was, how soon can we have the video and the slideshow posted for people?
Well, this video is going to take hours for Zoom to process, and then an hour to put it on YouTube. But as soon as I hit stop share, it'll start creating the Zoom version. I'll put it up this afternoon.
Okay, great.
Yeah, sound good? Okay. All right. Shall we adjourn the meeting? Okay, I think everyone's having a good time. They're on their way. Stephanie, Andy, any final thoughts?
Just see everybody Wednesday.
Okay.
See you all Wednesday.
Good job, everybody. Bye.
Thank you. Bye.
Thank you.